Oh, that's actually a semi overview. Buttons do 4 things. Each one. Good evening. So this is part 3 in my series on how to configure the serial ports for the Beaglebone Black for Ubuntu Snappy. This has primarily been the workstation I'm using to do all my work is on version 15.10, and it is for Ubuntu Snappy 15.04. I try to explain in detail how everything works so that when 16 comes out, you won't be trying to wade through with the complete blindness of how some of these documents are written out there that are pointless and overcomplicated. I found people like to overcomplicate things, apparently. So with that being said, also, by the way, I do have hosting that I resell through GoDaddy, and I have all my price points set at the very lowest, so you'll get better rates than if you buy directly from GoDaddy, and those aren't sale prices. Those will be always the continual price. I set them to the bare minimums for domain names and everything else, and so the renewal fees will be as much as your first year, as opposed to when you order from GoDaddy, they go up. So if you would like, you can support me by going to store.robotjtech.com. And if you need hosting, also, like if you're doing stuff with Adobe Muse and your web host doesn't let you enable PHP support on the .html files, if you watch my video, the HTML to PHP for Adobe Muse, if you have questions like that, again, I can do that. I can host you, and we can turn that on for you pretty easily on the GoDaddy server, and you're going to get it for around $3 a month. And so check that out. I greatly appreciate the business. Again, if you have any questions and support questions, you are free to also contact me outside of the normal GoDaddy support number if you're buying services from me. So let's get to what we're going to discuss today. And just to summarize part 1, I showed you how to simply enable the serial ports UARTs 2 and 4 on Debian by enabling the device tree overlay files, and explain what the device tree overlay files are. So if you don't know what those are and you don't know what I'm talking about, then you should start with part 1. Then in part 2, I show you how you can basically convert the device, the DTB file, which is a binary file, how you can convert that to a readable source file. And then once you convert the Beaglebone device tree file to a source file, you can edit in the text editor, and at that point you can add those overlay values to enable your UARTs. And so in that part 2, I show you how to enable UARTs 1, 2, and 4, and then you can simply recreate the directory, the device tree as a binary, and then upload that to your uboot folder on your Beaglebone. So that's pretty much what step 2 is about. Step 3 is the final part of this series, and this is how you can roll it all up into a nice little image that contains your new device tree with the serial ports enabled, and it's an image that you just flash to your drive, to your SD card. And so that's where we're going to start with this today. And so again, I'm going to just run into my shell. I also set up some shortcuts for you. So I'm going to just pull this up at GitHub. It's GitHub robotjtech. And you're going to see there, you're going to see Beaglebone Black Snappy UART enable UARTs. And so I've made this nice little project here with manuals that's going to discuss everything I'm talking about. So again, if you want to just play with just doing the DTB files, I already got one here that has the UARTs enabled. I have it uncompiled as well, just the source of that. And so you can play with that. Again, there's a link to part 1 right here. So you can go to the very first tutorial in this series. And so that's if you want to, if that's all you want to do, and you don't want to build an image, and you want to just enable your UARTs, you can just drag this to your U-boot folder and the DPTS folder under U-boot, and you will have what you need. Again, this takes you right to part 1, but then part 2 will actually show you where to put these. Part 1 just explains what these are. So now we have another directory called oem.snap that I've made here for you. And I also have, if you know how to make a snap, if you know how to make just an image using the Ubuntu Flash application, you can just use this oem.snap, and that is ready to go, and it has the serial ports already enabled, and then you can snap that right into an image file that you can burn to an SD card. And the login will be, of course, Ubuntu with the password of Ubuntu. So basically, you would just take this snap, drop it on your hard drive, and then you would just run this command right here, which I will get further into when I show you how to do it all. You run this command, and that will create you an image that you can then burn to a drive, SD card, sorry. So let's get into this. What we're going to cover, though, is the details of what all happens when you make this. What is the snap, oem.snap, and how can we add more changes to it? And that's really what I wanted to get in here, so that you can learn how to actually build an oem.snap, build a custom image with other devices if you want, or other apps already installed on the images you want. I'm not going to get into the other apps part of it, but this is important to know, because if you want to do that, you have to be able to build the entire oem.snap to begin with. So I'm going to show you how to build that oem.snap, and then I will follow up with the final commands, which I show right here. So here we go. Okay, so we've got everything we need in here. I'll just show it to you real quick. And again, these are the components that you have to have to build a snap. Now, this is just the README doc that you have down here. But this is our device tree that we are going to include in this snap to override the normal Beaglebone device tree to enable our UARTs 0, 1, 2, and 4. You have your U-boot image, and you have your memory loader image, and then you have your meta. The meta folder is what's used to actually tell Snappy how to build the snap. It wants a little README doc. Then you have your package file, and then I have a little icon here. So I will get into Shell and explain what those do. But to get started, we're going to just download this whole package, and we're going to just download the whole thing. So let's run over here to Shell. I'm going to make a new directory, snappy image, and I'm just doing this to get out of the way. And so I'm going to go ahead and get that whole thing with all my stuff in it that I just showed you. Okay, so in here we've got your, let's change there. So here's our everything we got here. So where we want to go is into the oem.snap directory. And basically, inside the oem.snap, like I said, we have, if you wanted to just burn this, you could burn an image of it right now. But we actually want to build the source, and I'm going to show you how to build the source, so so that you can create your own oem.snap. So let's go ahead and get started. So the first thing you're going to need is the tools, and Of course, you just saw me just download the actual my actual package that I'm talking about here on the page. But I'll explain this little list here. We already have Git installed. I've already got all these installed actually, but this is basically just telling it to install Git, the build essentials package, make GC, and this is the important one right here. This is what allows you to compile code for the ARM processor on an Intel chip. So this will allow us to cross-compile for a different architecture. So very important, you got to have these or nothing's going to work. So let's go ahead and copy this. And again, I already have all this installed, but I'll just show you what would happen. Mine's just going to say there's nothing to do because it's already there. So we hit enter, and then it'll go through and it'll say, do you want to install this? And you just say yes, and it'll put those all in the systems. Now, once you've gotten that, basically, once you've gotten that, you're going to take and we want to download the U-Boot source tree from the company that is in charge of developing U-Boot. So we're going to go ahead and copy that line. It uses Git to get it, just like I used Git earlier to get my project, and we're going to download U-Boot. And so by having all this source, you could actually compile U-Boot to do for many different boards, but by using this technique. And so you can also tweak the config file in the U-Boot source, even for the Beaglebone Black. However, we're not going to do any tweaking to the U-Boot image. You don't actually have to do this step. You could just use my source image that I've already provided in the build source tree. But if you want to get like a newer version of U-Boot for whatever reason, this would be handy to know. And I'm going through the steps to show you anyway, just because it's good to know the process of what is the U-Boot image and what is really involved in it. So once this gets downloaded, we are going to basically compile a U-Boot image for the Beaglebone Black. Now keep in mind, the U-Boot image is not what actually takes care of your device tree. Like I say, you can actually do some controlling with that, but that's not what we're trying to do. We're not trying to do that through the U-Boot image, but it is required in order to create a snap, an OEM snap. All right, it's just about finished. This is quite a timely process to download it. It's quite large, as you noticed. There's like 765,000 files. So we are now going to change to the U-Boot folder. This is what we just now downloaded. And so this folder has basically some default configs. If you look, and in that, all those default configs, you are going to find one for the Beagle. And there it is. So this is the config file for the Beagle. And it's just a default set of configuration options for building U-Boot for the Beagle. You can make changes to that. However, this tutorial is not going to get into that aspect of it because that's not necessary to make changes for the device trees. So, but that'll be down the road, another tutorial for some other day. But this is just handy to know if you ever wanted to build custom boot images for other type of boards. So with that being said, the next thing we're going to do is we need to make a config file. The .config file has to be created so that when we compile, it will know how we want to build it. So we are going to run this, and we're basically telling it to use the cross compiler here. This was the ARM cross compiler we downloaded, so we can compile this to be compatible with the ARM processor. And then this is the config file that we want to use. This information, this file is what we want to use to build that config. And so we're first going to build the .config file. And so we just copy that line, and we just run it. Once we built the .config file, The next thing we want to do is actually now build the whole, compile everything here in this directory for the ARM processor and give us a boot image and a memory loader image file. So we'll end up with a u-boot.img file and a MLO file. All right, so now let's go back in here, and there you go. You're going to see it created a brand new, there it is, right here. We have this, and we also have this. So there we go. We got the two files we need. Now we can go back up here, and again, I have a build source directory. All right, so we've got all that downloaded. We've got it all compiled. Now, just to review, we have a directory called build source in the package that you downloaded from my GitHub. And in there, again, you can make changes to this go to the step 2 video to find out how to edit the DTB file, but you could just make changes to this DTB file and add whatever devices you want. So you don't have to necessarily create yourself a new U-boot image or a new MLO unless you're just feeling like you need to, or if there's for some reason that you have to when the 16 point whatever comes out of Snappy. But at this point, you could just use the one I have, and it'll probably suit you just fine. But now you've been shown how you can create your own new boot image. So then you would just copy the images we just made, and you can just copy them right into my directory. You can just copy them right into my directory and overwrite the ones that I have in there. So that's all you need to do to create those two things. Now, let's go ahead and go into the build source directory. And you will see when you look at these. There you go. You can see the new ones I did at 854. I just built those, whereas when I originally extracted mine, it was all extracted at 820. So we've got our new MLO, we've got our new U-boot image. What do we have in the U environment? So here's what we have in the U environment file. Basically, you shouldn't need to make any changes to that, but there it is if you wanted to. Then the next thing we have is, of course, our DTB file, which again, go to the step 2 video if you want a full explanation of how that file works and how you can make changes to the device tree with that file. That's completely covered in step 2. So we have our DTB, we have our images, we have our UNV, and then we have in the meta directory. This meta directory is what's used to tell Snappy how to build the actual snap. And so we have a few things in here, as I covered before. We're going to have the README file, which that's obvious. We have an icon, which is obvious. But now we have the package. So what do we have in the package? And this is important. So you basically put the name of the package. Pretty self-explanatory. You have your vendor name. It has to be an email address. So we have an email address in here. We have the location of the icon, and this is the root of this is always considered the directory up. So meta is inside the root of the snap package directory. So you don't put .meta or anything. You could, but that's all you have to put. This is version 0.1, and the important thing is we need to say it's an OEM snap, not a gadget or anything like that. So you're saying the type is OEM. And so then we're going to do some basic configuration stuff. We're basically going to make it so the host name shows up as robotjbeagle. Like I say, when you go and look at your DHCP hosts that are connected to your router, you'll be able to see Robot JTech Beagle. And then we want to make sure that for services, you want to make sure SSH is enabled. Otherwise, you are going to have to hook up to this using a console connection, which is just a pain, unless you need it for some reason. Again, for security, you can disable SSH, but for this purposes, this is how you turn it on. Branding is obvious. Again, logo is obvious. Then here we have the platform. This, of course, is the Beaglebone Black platform. The architecture is ARM-HF. Now, notice the DTB file. When you created an image using the Ubuntu device flash, it downloads a device tree with all kinds of stuff in it. All the device tree files and all kinds of stuff. What we're saying is we do not want to worry about that. We want to use this file that I just showed you in the root of the snap folder, the source build folder. This is what we want to use as our device tree. By doing that, then when you compile this, all the devices we have set up in it is what's going to work, including all the serial ports, because that's what I have enabled in this device tree. Well, not all of them, but 0, 1, 2, and 4. Then the partition layout. This is basically for the the transactional updates of the actual kernel and such. By having this, it has, if it boots and fails, it can roll over to the other partition layout. So you can boot from partition A or boot from partition B. Again, we are using the uboot loader, so we don't change that. And then the assets that we're going to use for the boot is, of course, as you know, the env, the memory loader, and the uboot image. That's pretty much it. The only thing you are changing really is this package file. All you're really changing to make it support whatever device tree file name you want right there. And that's what gives you the ability to do that. So once you have that file created, how you need, then you're ready to build the snap. So we're going to change back to the root of the source tree. And here we are in the root. And we are going to type snappy build. And basically, that's it. We now have a OEM snap right here. So with this OEM snap created, you can now burn a flash. So let's go up to the top here, and we're going to just use this command up here that I have already written out to show you how to do that. Now we're going to make a slight modification to it because this command, okay, let me explain it real quick. So super user, run as super user. This is the command, Ubuntu device flash. If you don't have it installed, it'll automatically say, hey, go ahead and install this, and you run the command that it tells you to run, and it will install. We're installing Ubuntu Core, Snappy Core, version 15.04. The output file is going to be called mysnappy.img, and the channel is Edge. Now, what channel means is what release of 15.04. So basically, if you say channel stable, it's going to be the stable release. If you say channel Edge, it's going to be the most current release. So that's why I used Edge. You can redo this as stable if you prefer. Then here's the name of the OEM snap. Now, of course, in this description here, I have it because this is the instructions to compile for this file right here that's in the package you downloaded from my GitHub. We're going to have to change that name because, as you can see, when it built a new one, it's not that name. So we're going to change that name. Again, we say here, enable SSH. I put this anyway. I'm not sure that I need it, even though that I have it in the package YAML. So I may not need this. However, I discovered just having this alone is not enough. So, but for intensive purposes, and I know this doesn't prevent it from working, I just leave that in there. And then, of course, we want developer mode because we haven't signed any of these packages. And so we basically use developer mode, so that it basically will allow us to package all this without having any signatures. So we are going to take this whole line, copy it, paste it, and we're going to go back here, and we are going to replace this part with the actual name of the snap we just created. And now we're going to just hit enter. Put our password and wait. It'll download the device packages and stuff online and the 15.04 core image. And then once that's all downloaded, it will overlay with the Ubuntu, the OEM snap that I just created. All right, so there we go. We have an image. So let's look in here. So there we go. It's just under 4. It's just at 4 gig. So you'll need at least a 4 gig card to store it. But there's your image, and now you simply burn it. Once you've plugged your SD card in, you basically would say the device name of the SD card, and you would put it here. So device / whatever. Some notes, for example, on a Mac, it's going to be disk, like disk 2. Make sure you're not obviously overwriting the drive. You want to make sure that the SD card is unmounted. It won't let you write to anything that's mounted. So when you insert your SD card, you need to unmount it. But for example, if it was on a Mac, keep in mind, you're probably going to have to use a number like 32 meg. This value on certain OSs can be picky. I've seen some people type it like this, and certain formats of how you type that just won't work. So keep on mind, like if you type it, this is how it would be on a Mac. This is how you would run this command. 32 with a lowercase m, and for example here, and I don't have a disk 2, obviously, so it's going to fail. I don't know what I wrote to just now. Probably just erased everything. Oh, no space left on the device. So, because it doesn't exist. But, so anyway, if the 4K doesn't work on your Mac, change it to something like 32M. Doesn't really matter. It just has to be lowercase. So, there you go. That'll make your image. Plug it into the SD slot on your Beaglebone Black, boot it up, and you're ready to go. Again, you can just log into your router, look for the DHCP IP address that was assigned to the Beaglebone, and just shell right in. The username is Ubuntu, and the password is also Ubuntu. And that is it. That is how you create a completely custom snappy image. It's not nearly as hard as everybody wants to make it out to be.